While we're figuring out the material, let me just introduce myself. So my name is Craig. I'm a Vice President of Research and Development at VMware. And for those of you, how many of you have sort of heard me speak before? Okay, a couple. Okay, so most of you don't know me. Great, so I'll introduce myself. My background, I spent a bit of time at Google. I was responsible for building out Google Compute Engine, which is an infrastructure as a service platform. And it was a fun project because we got to bring relatively traditional workloads into the Google environment. And we got to really experience some of the power that building on technologies like Borg allowed us. But what we'd done with that technology was create a sort of basic infrastructure service offering, and we were a little bit late to the market. You know, Amazon, in my mind at least, had already achieved escape velocity. So the second project that my friend Joe and I built was Kubernetes. We started the Kubernetes project while we worked inside Google. And obviously, it worked out pretty well. I mean, there's a reason that you're all here today. And that's perfect.
Yes? Okay.
Thank you. All right. So what I'd like to do is kind of reflect a little bit on what Kubernetes is. I mean, how many of you consider yourselves expert in this technology? Experts in Kubernetes? How many of you just won't raise your hand at all? Ever? Okay. Maybe this is welcome to Germany, right? So let me just kind of provide some framing around what Kubernetes is. I'm going to talk a little bit about the technology, describe it from a couple of different perspectives, but also hopefully give you a sense of why it is so powerful, like what made Kubernetes really stand out as an orchestration technology. So let's kind of start there. What is Kubernetes? Kubernetes is a Linux application container orchestrator, right? That's one way to look at it. It's a way to get a Linux application out into a fleet of machines in an intelligent way. That's one way to think about it. A lot of other people start to talk about Kubernetes is an API for distributed systems development. It's a way to start thinking about describing an ideal infrastructure environment into which you can deploy an application. So that's another way of thinking about it. But what is Kubernetes really? Like, you're probably all, okay, let me try this hands thing one more time. Like, you got to bear with me now. How many of you think of yourselves as systems engineers? Okay, that's good, right? So from a systems engineer's perspective, one way to think about Kubernetes is it's just a database. Kubernetes is just a database and a set of controllers that enable you to take an expression of state as written into that database and materialize it into the outside world, right? So this is a slightly kind of deconstructionist way to think about Kubernetes. Like, at the heart of it, it's really just a database into which you write a declarative expression of how you want the world to look. And then it's a well-structured and well-formed layered set of controllers that enable you to take that expression of state and drive the world into that desired outcome. And at the heart of it, this is what makes the system so powerful, right? There's been a lot of different technologies that have aspired to deliver this container orchestration set of patterns. And when I think back on the sort of origins of Kubernetes, one of the folks that was a part of that sort of founding crew was this guy, Brennan Burns. I don't know, how many of you are familiar with Brennan Burns' work? He works at Microsoft now, right? So I always like to describe Brennan as this sort of Renaissance man. He's always fascinating. He can draw, he can run, he can code the hell out of things. He's a really fascinating guy. But he's also a robotics professor, like in a past life. And one of the things that we thought a lot about during the early days of Kubernetes was this idea of reconciliation loops, of modern control patterns. How could you apply those modern control patterns to a distributed systems environment? And we leaned into a lot of the learnings that came out of the sort of these very smart engineers that worked inside Google on technologies like Borg and its successor Omega. And at the end of the day, what the engineers, and I don't consider myself one of the key designers of Kubernetes. I was more just the spokesperson, business guy, person kind of bringing a lot of it together. Like these engineers that really sort of worked on it and designed this, thought about it this way, which is if you can create an isolated atom of control, if you can describe something such that there's a controller that has a single purpose in the world, its entire utility is taking an expression of declarative state and driving everything within its domain of authority into that state, you create a far more intrinsically and naturally scalable system, right? So if you think about a lot of the other orchestrators that exist, they always had these kind of centralized control metaphors where I have this one mega controller. It makes all of the scheduling decisions for everything. It becomes the sort of single authority of truth, and that becomes a gating factor on its ability to scale and its ability to be kind of intrinsically extensible. And Kubernetes really kind of shucked that. And like last year at ContainerDays, I talked about this sort of notion here. When you end up with a system where you have distributed controllers, where you have these controllers that understand their role in the world, and then they understand what other controllers need to exist, so this sort of elegantly nested set of controllers, you end up with a distributed system that acts more like jazz improvisation than a sort of classic orchestra. The controllers can interact with each other in intelligent and smart ways to drive what they understand into a desired shape, a desired outcome for the broader system. And as a result of this, the operating behavior of Kubernetes is kind of fascinating. For those folks that have spent time with the system, I remember I was in Texas this one time, and this guy said, it's a shotgun-proof system. Like I could shoot the rack with a shotgun, and everything would just kind of work. I was like, okay, please don't do that, right? Like, I don't think it's a good idea. But the idea that you've introduced a lot of these kind of nested control elements into an environment like this becomes really powerful. The system becomes self-regulating. The system becomes self-writing. The system is able to deal with situations which the operators cannot necessarily perceive, but it can only do that because each of these controllers is operating in a very scoped and isolated way. And as a result of this, I think one of the things that's most powerful about Kubernetes is it's a great way to deal with inconsistency in an environment, right? Like this is one of the things that I always talk about, when you're a distributed systems engineer, you can deal with complexity, right? Like we engineers love complexity. Like we'll often add complexity for no particular reason, right? It's something that we often relish. Now, we shouldn't necessarily do that, but it's kind of like a guilty pleasure. But the one thing that I've always hated as a systems engineer is inconsistency. It's that idea that you can't necessarily plan for that environment, that event. You haven't seen that peculiar 5 sigma, 5 standard deviations of normal event. You don't know when your cloud-based workload is going to get spun up next to a Netflix transcoding workload, and everything's just going to go slower. One day in 1,000 that you just have never seen before. And so the nice thing about a technology like Kubernetes is that when you can start to express a lot of these constructs as control loops, you're able to rely on the system to drive itself into a coherent state, into the desired outcome that you're looking for. And it becomes very powerful. It really leads to a lot of those resiliency systems. I mean, I've worked with organizations out there, and I've had an engineering manager come to me and say, like, wow, I'm not sure about this Kubernetes thing. I was like, why? It's great. He's like, no, it's because my engineers are writing worse code. And I was like, what do you mean? It's like, well, in the old days, when something went out of memory, they get paged and have to go and fix it, and they get kind of resentful, so they go and figure out what happened and fix it. These days, Kubernetes just deals with it. That you have the health checks and things just get restarted and everything just gets driven to these states. So I'm pretty sure the engineers are writing worse code. I was like, okay, well, that's an unexpected secondary effect, but it exists. But for all of this to really kind of achieve the most possible impact and the best possible outcome, you really want to start thinking about these patterns beyond the realm of Kubernetes itself. Right? And this is something that it takes people a little while to get their heads around. But if you start really thinking about it, Kubernetes is just a database. It's able to drive a system into desired state. Okay, that's really powerful for pods and replica sets and all of the Kubernetes sort of first-class primitives. But what about above Kubernetes, and what about below Kubernetes? Can we take a lot of these constructs and apply them to managing the infrastructure domain? Can we start to represent the infrastructure as custom resource definitions? Can we start to enable these reconciliation loops where you're using Kubernetes to actually drive the shape of the underlying infrastructure itself? And then can you also start to express some of the first-class application level primitives as entities that Kubernetes understands in a first-class way, so Kubernetes can drive them into a coherent state? And so let's start with the infrastructure piece. This is actually something that I'm going to give a shout out to the Lutz folks. They've been organizing this conference, and they've been thinking about the world this way for quite some time, right? So how do you actually start to express the infrastructure as primitives that Kubernetes can drive through reconciliation loops? So if you've had a look at things like Kubernetes, they've been doing good work in this space for quite some time. But the whole idea is, well, that's fantastic. Now, how do we kind of genericize that? Like, how do we get this into into the community through a first-class set of activities in the Kubernetes project. And one of the things that I've always been kind of passionate about as a member of the Kubernetes community is avoiding this idea of the tragedy of the commons, right? So one of the things that I've always sort of seen with vendors that exist in this ecosystem is they will put a lot of time and effort into making something work in upstream if it's interesting. But often as not, the operationalization of the technology itself is something that they've always looked at as being kind of commercially interesting. Now, one of the things that I really like about the Kubernetes community is, we're actually working as a community to address these challenges in a first-class way. As a community, we're coming together to figure out how to operationalize Kubernetes using Kubernetes primitives. So there's an active special interest group called SIG Cluster Lifecycle, of which a lot of folks are kind of active and participating. And they're introducing this idea of Cluster API. It's something to take a look at if you haven't seen it yet. And what we're doing with Cluster API as a community is looking to sort of really enrich those sensibilities around Kubernetes as a substrate to manage Kubernetes. And that has a lot of advantages. It means that, one, as a consumer of Kubernetes, you're not necessarily going to be tied to a single vendor, right? So you have a lot of choices. You have a lot of choices in terms of the operationalization. As this technology becomes embraced by the cloud providers, you could expect things like EKS, AKS, GKE to have a lot of consistent operating sort of practices with some of the other things that are coming out of vendors in the sort of in the distribution context. But more importantly is we can rely on the community itself to ensure that upstream Kubernetes works well everywhere and can be driven by Kubernetes everywhere. So this is something that I definitely encourage you to take a look at if you haven't seen it yet. But there's another area of the space that's worth paying attention to, which is how do we kind of raise up the view and rely on Kubernetes not to just drive those first-class named entities that Kubernetes understands, but bring that into the application domain. So start to think about, hey, I have something that's a little fancier than just a sort of single container expression. I want to deploy this thing that has a number of different moving parts. The upgrade semantics become challenging. I need to be able to upgrade this, then upgrade that, then signal this, etc. And one of the things that a lot of folks have been doing in the community for quite some time is introducing the idea of the Kubernetes operator. So how many of you are familiar with the operator patterns inside Kubernetes, right? Like, pay attention to this if you haven't looked at it. It's an incredibly powerful way of thinking about the world. I can now express, a relatively complex piece of application logic as an operator, and I can rely on Kubernetes to drive some of the reconciliation pieces. Now, it's really interesting in terms of creating this kind of SaaS at home experience, right? Like we're kind of at a tipping point of an industry where there's a lot of folks that are saying, hey, the future is going to be largely grounded in the sort of mega cloud providers delivering these kind of first-class integrated experiences. And they'll do an amazing job with that. There's another set of folks that are saying like, wow, maybe the open source ecosystem will be a primary driver of innovation, out there in the wild. Maybe that's the case. But the one thing I can tell you is that we're living in a time where the computational fleet is getting more fragmented rather than more consolidated. And it's peculiar. You'd think that with the introduction of the mega clouds, you'd start to see this incredible consolidatory force where all of these workloads are moving into these mega data centers. But it's actually going the other way. We're starting to see a world where edge deployments are becoming a reality for a lot of folks. Like I'm seeing an inordinate amount of computational resource getting pushed out into the edge by the telcos and the retailers and a lot of other folks. GDPR is happening. Whether we think it's, I actually think data privacy is a great thing, but it's definitely adding complexity to our deployments. We're starting to see the same behaviors emerging in the United States. And so if anything, the world of the computational fleet into which us distributed systems engineers are delivering our technologies is getting more intrinsically fragmented rather than becoming more consolidated. And we are going to need to be able to create the SaaS at home-like experience. Like we're going to need to be able to take a third-party piece of software, drop it into a Kubernetes environment, and rely on it to be largely self-managing. Or we're going to want to be able to do that for the software that we build ourselves, be able to drop it into one of these sort of highly fragmented environments and make sure that it is self-regulating, self-maintaining, self-updating, and self-running. So pay attention to the operators' practices. Now, the interesting thing is where these two worlds come together, right? So this is something that's worth thinking about. But like, for those of you that really sort of pride yourselves on distributed systems engineering, you might be saying like, hang on, Craig, like, this is one heck of a layering violation problem, right? Like, if you start to think about what we're doing with the operators, we're bringing third-party code into the Kubernetes control plane in a relatively intimate and direct way, right? And it's worth just understanding that. You know, from my perspective, I actually think it's worth it. Kind of sorry, not sorry. Like, I recognize the layering violations, but the power of this and the utility of this is really effective. But it is worth recognizing that as this becomes the norm, as we get into this world where you get more and more sort of application-level code having direct access to the Kubernetes control plane, it's going to introduce some peculiar third sort of, you know, secondary effects that we haven't necessarily thought through. And a pretty common deployment topology that we're going to start to see is a more fragmented deployment topology, which brings us right back to that first point. Having the ability to press a button and have something turn up Kubernetes clusters for you is a really good idea, because whether you like it or not, we're going to be living in a world of a lot of smaller clusters for a while before we start to see the consolidation to a small number of larger clusters. So with that, I'd like to say thank you. You know, I will be hanging out there in the VMware booth right in the corner. If you want to come by, say hello, talk about anything. And I hope you have a fantastic day, and we'll see if Ihor is around. Otherwise, I'm happy to talk about something else. Sebastian. All right.